Hi dear students, I am Fakhra Hashmi. I am your physics teacher. Today we are going to learn about the kinematics part 2. We have discovered already the kinematics part 1. You can also check it in the description box. So let's start it.
How can you find the equations for any one-dimensional motion with any constant acceleration? If you have already learned that velocity is basically rate of change of displacement, or you can say that change in position with respect to time will give you the velocity. And similarly, the average velocity can be written as some initial velocity plus some final velocity divided by 2. So this is my average velocity. So if the initial velocity is 0 of any object and the acceleration is considered to be constant, then you have average velocity would result into half of your final velocity. So you can solve it for final velocity. So assume t naught is equal to 0, so your change in time would result into your final time. So acceleration, if it's constant, so the velocity can be written as rate of change of displacement x minus x naught divided by time, because here t minus t naught is equal to t. So the velocity would result into x minus x naught divided by t. And as you know that x, if someone asks about your displacement, so x can be written as x naught plus vt. So here the v is the average velocity, which can be written as v naught plus v divided by 2. So you can put the values of average velocity over this equation. So you will get x is equal to half of v naught plus v of t plus x naught. So if you have asked about the acceleration, so acceleration is basically rate of change of your velocity. Your final velocity is v and your initial velocity is v naught. So v minus v naught divided by t is your acceleration. So v minus v naught would result into your at. So here the final velocity can be written as v naught plus at. So this is your first equation of motion. Now you know that velocity is equal to v naught, some initial velocity, some acceleration times your the time covered by your object. The value of v naught plus v can be written as at plus 2 v naught, as you have added to v naught on both sides. So you would result into 2 v naught over here. So if I have divided 2 from whole equation, so this would result like this. And so finally the average velocity can be written as half of at plus v naught, because x is equal to v of t plus x naught. So x is equal to half of at plus v naught, because v average would result like this. I have just replaced the value of v bar over here plus x naught. So x would result into x naught plus v naught of t plus half at squared. So this is your second equation of motion. As you have already described that your final velocity is equal to some initial velocity plus some acceleration times time. The time can be written as like this: time is equal to v final velocity minus some initial velocity divided by acceleration, and v average can be written like this: v naught plus v divided by 2. So I've just put the t and v bar value over here. X is equal to x naught plus v bar of t. So finally I'll get x is equal to, this is the value of v bar, that is v naught plus v divided by 2. And if I'm going to put the value of time over here, so v minus v naught divided by acceleration. So I'm just going to simply multiply it like so: x is equal to x minus x naught would result into v square minus v naught square divided by 2 of acceleration, and it would finally be written as vf square minus v initial square over 2a times some distance. So this is my third equation of motion. Again, we are using the concept of displacement with the help of average velocity. X is equal to x naught plus v average of t. So v average can be written as some initial velocity plus final velocity divided by 2. So v can be written like this. If v would be written over here, so v is equal to at plus v naught, as we have already described this relationship. So we are just going to replace this value into this equation, and then this v bar into this equation. We will result into x is equal to x naught plus v naught of t plus half at square. So this is again the third equation of motion. So these are some examples of your equations of motion with constant acceleration. So if a plane starting from rest accelerates to 40 meter per second in 10 seconds, so this is your velocity and this is your time. So how far did the plane travel during this time? So it is going to start from rest, so v naught is equal to 0, and it is going to accelerate with final velocity like 40 meter per second, and this is your time. So what would be the possible distance for this time, 10 seconds? So you are just in the data of your problem. So you are going to ask about your velocities. First of all, you have to calculate the average velocity. Average velocity would look like 0 plus 40 divided by 2. So this would result into 20 meter per second. You just have to put the value of average velocity over here and time over there. So you would get the final distance. So 20 meter per second into 10 second plus your initial distance is 0. So your final distance would be 200 meters. So plane is going to travel to 200 meters during the 10 seconds. So to avoid an accident, a car decelerates at 0.50 meter per second square. So if a car is going to decelerate, so it means you have negative acceleration, your velocity is going to decrease, or your velocity and acceleration are in opposite direction. So this is your time, and it is going to cover 15 meters of the road. What was the car's initial velocity? So we have to find out the velocity, that is v naught. So the given data can be written like this. So I'm just putting the all the data in my second equation of motion, that is x is equal to x naught plus v naught of t plus half a t square. My x is given 15 meter, my x naught is 0, and v naught I have to find out. V naught times 3 seconds plus half of a is minus 0.5 meter per second square, and t is 3 seconds square. 3 so t square is equal to 3 square. So if I'm going to solve this equation, then I'm going to get the velocity, that is 5.75 meter per second. So your car would have initial velocity 5.75 meter per second. So equations for one-dimensional motion with constant acceleration. Again, another example. A cheetah is walking at 1 meter per second. This is my velocity of object, and when it sees the zebra 25 meter away, so this is the distance of two objects, that is 25 meters away. What acceleration would be required to reach 20 meter per second is that distance. So you are just going to have the final velocity, so you just have to cover the distance to for cheetah to reach at zebra. So this is my final velocity, this is my initial velocity, and this is the distance, that is x, and x naught is equal to 0 because initially that is at 0 position, and acceleration I have to find out acceleration. I just have to take the third equation of motion and put all the values over there. V is 20 square, V naught is 1 meter square plus 2 times of acceleration. I have to find out acceleration. Then final, the distance 25 minus 0 would result into there should be some equal sign. So if I'm going to ask about your acceleration, so I just have to solve this equation to get acceleration, that is 7.98 meter per second square is the required acceleration to reach at 20 meter per second to 25 meter away distance to reach cheetah to zebra. So you can take different examples, and you can solve it by own. Thank you so much for your interest.